Okay, we have 3.4, factoring polynomial. You should already know how to factor your quadratic polynomials from integrated math 1 and integrated math 2, but integrated math 3, we're going to factor some polynomials. Okay, I'm going to need to adjust that. There we go. So how do you factor x squared minus 8x plus 12? Now it's called factoring by sums and products, and there's many ways to do it, but the basic method, the basic concept is we want to get negative 8, two numbers to add to negative 8, and to multiply to 12. So in a quadratic function ax squared plus bx plus c, we want to have two numbers add up to b and multiply to a times c. So add up to b and multiply a times c. So add up to b and multiply to a times c, which is what we've set up right here. So this is called the snowflake method, and the numbers, we put the add up to b, we put that at the bottom of the snowflake, and the multiply to a times c. So a is just 1 in this case, and then c is 12, so 1 times 12 is 12. Okay, and then we put a's on both sides, put a's on both the sides, and we factor. We find two numbers that add up to negative 8, multiply to 12. In this case, it will be negative 2 and negative 6. Negative 2 times negative 6 is 12, negative 2 plus negative 6, negative 8. So this is our result right here. This is the coefficient, and that's the constant. So we'll have x minus 2. Minus 2 is a constant, right? The coefficient in front of the first number. And then x minus 6. That's the constant, and that's the coefficient. Okay, next. You could also separate these two numbers to try to get a factor by greatest common factor. So in this case, it will be x squared minus 6x, which will be x times x minus 6. You factor the first two, and then you factor the last two. And then you see it, hopefully there's a greatest common factor in between them, so you can factor them. Now, we don't want a negative in, we want to factor the negative out, because we don't want a plus and then a minus. That's just annoying. So we just do minus 2 times, and then x minus 6, because minus 2 times minus 6 is 12. So then these two both have a greatest common factor of x minus 6. So we can do x minus 2 times x minus 6. And that's another way to factor it. The third way is just, there's nothing fancy about it. Just list out all the factors and see which ones add up to negative 8 and multiply to 12. So it can't be any of the positive numbers, because 1 plus 12 is 13. A positive number add to a positive number gives you a positive number, not a negative. It can't be any of the positive numbers. Negative 1 plus negative 12 is negative 13, not negative 8, so that doesn't work. Negative 2 plus negative 6 is negative 8, so that works. So we're going to choose that. And this adds up to negative 7, that doesn't work either. And then we can just write it out. X minus 2 times x minus 6. And that's the answer. And then we multiply it out using the FOIL method. We'll get x squared minus 2x minus 6x plus 12, which will give us x squared minus 8x plus 12. So the factoring method does work. Next, we have factoring by special property. So these are the special properties. I really recommend you remember this. I really recommend you remember all three of them, but you have to remember the first one, difference of squares. So we have x squared minus 60. You have to know that it's x plus 4, x minus 4. If you don't know this, you will fail the next test. Okay. Otherwise, that's pretty much all you really have to know, because I'm pretty sure that your teachers aren't that cruel for you to have to remember this sum of cubes and difference of cubes formula, but you might have to as well. So I recommend you remember all three of them anyway. I don't require you to do anything. So, for example, in this first equation right here, what's the greatest common factor of 4x to the 5th and 32x squared? So the greatest common factor of the coefficients is 4, and then the greatest common factor of x to the 5th power and x12 Now x2 is x2. So 4x to the 5th divided by 4x2 is x3. And then 32x squared minus, divided by 4x squared is 8. So then we can use this difference of cubes formula. We'll get 4x squared times x squared, because x squared right there, right, plus xy. In this case, the minus 8, we have to make it as a cube as well, because it's a difference of cube. It's not one cube and then the other one's just not a cube. So we have to fix that to minus 2 cubed, because we want x cubed minus 2 cubed, the x cubed minus y cubed. Y is 2. So since y is 2, we can do 2x and then plus y squared, so y is 2, so 2 squared is 4, and then x minus y, so it's just x minus 2. And that's your factor equation. Next, what is the greatest common factor of the coefficients? It's 2. And what's the greatest common factor between t7 and t4? It's t4. So we have 2t4. And then we have 16t7 divided by 2t4 will give you 8t cubed, right? But 8t cubed, only the t is cubed, not the 8. So since only the t is cubed and the 8 is not cubed, we have to cube the 8 as well. So once the 8's cubed, we'll get 2 cubed, so then we'll have 2t, and then the whole thing is cubed, right? And then our 250t to the 4th divided by 2t to the 4th is 125. 125 is 5 cubed. So then now we have the x cubed plus y cubed form. And I think, yeah, okay, wait. So we can still keep the 2t to the 4th. Now we're going to use the sum of cubes. So we have 2t squared. What's 2t squared? It's 4t squared. And then minus xy. So minus 5 times 2t. 5 times 2t is 10t. Plus y squared. Y is just 5. So plus y squared, that's 25. And then our x is just this first number, so 2t. Plus our y, which is this last number, is just 5. So it's 2t to the 4th power times 4t squared minus 10t plus 25 times 2t plus 5. Okay, so our next question, 135 z to the 11 minus 1080 z to the 8. Now, you could try to find the process of elimination, which one is the greatest common factor, 135 and 1080. But I can tell you right now, it's 135. Okay, so 135, and what's our z coefficient that we have to take? What's our z that we have to take out? So it's the smaller one, so that's z8. Z8. So z11 divided by z8 is z cubed, and then 1080 divided by 135 is minus 8. Minus 8 is minus 2 cubed. So we'll have same thing as x cubed minus 2 cubed. This time we have z cubed minus 2 cubed. So we'll have 135 z8. And then z cubed will just be z squared plus 2z plus 4. And then we'll have x, since x minus 2, we'll have z minus 2. And that is the answer. I'm sorry if it's a little bit noisy, but you're just gonna have to deal with it. How do you tell if z is a root of the polynomial equation? So you want to tell if c is a root of polynomial equation. That means it has to divide into it and give out a remainder of 0 in order for it to be a root, because then f of something, f of x is equal to 0. And that's one of our theorems that we've learned. If f of x is equal, I'm really sorry about the door noises. But we're going to show if minus 3, negative 3 is a root of polynomial x to the 4 plus 3x cubed minus 8x minus 24. And then we're going to factor the remainder. We're going to factor the number that comes out of it. We're going to factor that. And it comes out pretty nice. Let me just tell you that now. So we're going to do synthetic division. If you don't remember from previous lessons, negative 3 is our root. Negative 3 is our root, so we have to add negative 3 right here. and then we'll have x to the fourth. So x to the fourth will be 1, 3, and then we have to have a placeholder for x squared, and then negative 8, and then negative 24. So we'll place 1 down. 1 times negative 3 is negative 3. 3 plus negative 3 is 0. Right? 0. So we have nothing to carry. 0 plus 0 is just 0. And then that'll be 0. Negative 8 plus 0 is negative 8. And then negative 8 times negative 3 is 24. Positive 24. 24 plus negative 24 is 0. So then we'll have 1, 0, 0, 8, negative 8, 0. So we have no remainder. So we can tell that negative 3 is a root of polynomial x to the 4 plus 3x cubed minus 8x minus 24. And then our 1 will have a degree that is 1 lower. So x4 instead of x to the 4, it will be x cubed. And then there will be no x squared, there will be no x, and it will just be minus 8. So x cubed minus 8. So then we'll have x. So since negative 3 is a root, we have to make it opposite. So x plus 3, so then we'll get 0 from this equation. Negative 3 plus 3 is 0. So the zero product property, according to the zero product property, 0 times anything will make it a 0. Therefore, it will become a root. So we've got to factor the x cubed minus 8 that comes out of this. And we can just factor it using the equation that we've learned on the previous slide. And I kind of got it down pat. It is x squared plus 2x plus 4, this is 2 cubed, remember that, times x minus 2. And that is our equation. Next, thought-provoking. Now this makes me laugh because it's really easy. Find a value of k such that f of x minus over x minus k is the remainder of 0. Justify your answer. We'll just find one. Okay, you can find the other ones by yourself. F of x is equal to x cubed minus 3x squared minus 4x. X cubed minus 3x squared minus 4x? What's the greatest common factor of all these numbers? It's just x. So x, we can factor x out of it. It will be x squared minus 3x minus 4. So our x, if we want a number to be 0 in order for f of x over x minus k to be have a remainder of 0. Therefore, x is just equal to 0. So then we'll have k equal to 0. Simple. That's it's nothing that hard. And then you can factor x squared minus 3x minus 4 to have x minus 4x plus 1, and then minus 4, and then 4 and negative 1 are your two other answers. So it can be 0, 4, or negative 1. Next question. Oh god, I skipped 2. We'll factor these other numbers. Now, our 8m cubed minus 343. 343, first of all, is 7 cubed, so we'll just put that down right there. 8 is 2 cubed, so we'll have 2m right there, and they're all cubed. So we'll have 8m cubed at the end. 2m cubed minus 7 cubed, we'll have a difference of cubes formula. So the first number cubed, the first number squared, plus first number times the second number, which is actually the first number times the second number, so 14m, and then the last number squared, so 49, and then we want to multiply that by 2m minus 7, and I think that fits. Yeah, 2m minus 7. Okay, next. What's the greatest common factor out of these three numbers? It's 2p squared. 2p squared, 2p8 minus 2p squared is p to the 6 minus 12p, 5 minus 2 divided by 2p squared is 6p cubed, and then 16p squared divided by 2p squared is just plus 8. So that's 2p cubed times 6p to the 6th power minus 6p cubed plus 8. This might seem unfactorable, but no, it's not. It's not unfactorable, because let's make this as a function of just p squared, and then this is just regular p, right? P squared minus 6p plus 8. If you factor this, you'll have p minus 2, p minus 4. These two p's multiply to become p squared. So p times p is p squared. p times p is p squared, and then p times -4 and p times -2, add them together, you get minus 6p. We can do the same for this one, but take p cubed as our thing, because 3 plus 3 is 6. So instead of our p squared minus 6p plus 8, we can just have it as p cubed minus 2, and then p cubed minus 4, instead of our p minus 4, because p cubed times p cubed will still give you p to the 6th. Next, 5x to the 5th minus 10x to the 4th minus 40x cubed. Greatest common factor is 5x cubed, and then x to the 5th divided by x cubed is x squared, minus 10x to the 4th divided by 5x cubed is 2x, and then minus 40x cubed divided by 5x cubed is minus 8. Now, which two numbers add up to -2 and multiply to -8? I'll give you a few seconds. Okay, it's -4 and +2. X minus 4, x plus 2. It's 5x cubed, I'm sorry. 5x cubed, x minus 4, x plus 2. Okay, 64. This might look a little intimidating, but the strategy is to factor, if you ever see 4 numbers like this, you can either find a common, root and test for root, or you can just factor the first two and then factor the last two. So in this case, 9, what's the correct common factor of 9k cubed minus 24k squared? It's just going to be 3k cubed, and then 9k cubed divided, 3k squared, I'm sorry. And then 9k cubed divided by 3k squared is just 3k, right? And then 24k squared divided by 3k squared is just going to be minus 8. See, and then right here, there's a 3k minus 8, and then there's a 3k minus 8 right here. So it'll just be 3k minus 8 again. And then this is automatic 1. So then we can just do 3k squared plus 1 divided by 3k minus 8. I'm really sorry about the noise. 3k squared plus 1 divided by 3k minus 8. It is coronavirus season, and I do have to deal with people talking over me. But I'm more like talking over them. So, reasoning, 74. Reasoning. This is the graph shown, and can you use the factor theorem to factor f(x)? Explain. The factor theorem basically just states that a polynomial can be factored into the sum. A polynomial can be factored, basically. That's it. That's the equation. That's the theorem. So, can this polynomial be factored over the real numbers? No, it cannot, because it doesn't pass this axis. It doesn't pass the x-axis. Therefore, there's no roots. So we can't do x minus a, x minus b. We can't do that, or x plus a, x plus b. So no, it cannot be factored using the factor theorem. It can be factored using imaginary numbers, but it cannot be factored using factor theorem. And I'm gonna explain to you that in 3.6. Next, critical thinking. Use the diagram to complete parts A and C, and this is really nice. This is the reason why I implemented this thing. So explain why a cubed. So I'm gonna draw this out right here. Explain why a cubed minus b cubed is equal to the sum of volumes of solids 1, 2, and 3. So these solids 1, 2, and 3 make up this whole thing, but missing this b cubed square. So the area of the missing square, so I'll just note that as m, is b cubed, but the area of the whole cube, the area of the whole is the whole w is a cubed. So the area of the cube, the actual area, no, the volume, I say, the volume, and volume. The volume of the cube is a cubed minus b cubed. Simple. So I have to write an algebraic expression for the volume of each. So it's just find out the volume of each of the solids. So we're not going to volume of the first solid. The volume of the first solid is just this part of the solid. So it's just this part right here. That's the volume of the first solid. It's length times width times depth. So it's just a times, and then this is a. This whole thing's a, and it's missing a b, so it's just a minus b, simple, which is equal to. Actually, I'll just leave it like that because part C is really nice when you leave it like that. Now the volume of the second solid is this side is b long, right? This side is a long, as denoted by this, and then this side right here is a missing b, so a minus b. So we'll have a times a minus b times b, and then b, the volume of solid 3, we have our this as b long, we have this as b long, and then we have this as a missing b, so it'll be a minus b again. So a minus b times, we have the two b longs. Use the results from part A and part B to derive the factoring pattern a cubed minus a cubed minus b cubed. So in order to derive the factoring pattern a cubed minus b cubed, you have to add all of these together. So we'd have a times a minus b plus a times a minus b times b plus a minus b times, oh god, a minus b times b times b. And that's the volume of the whole thing. So I've been telling you to look at the greatest common factor for all the time, for every single time when I tell you the factor, I tell you to look at the greatest common factor, because it actually comes out useful in this case. The greatest common factor of these three numbers is a minus b, a minus b, a minus b. Then we have a minus b out here, and then we'll have these two missing. So a times a is just a squared, right? And there's a plus, and then there's an a and b missing right here, so it'll just be ab, and then we'll have, I think it still fits. There you go, ab, and then we have our final two b's right here, so that'll be b squared. So then we'll have this factoring pattern where a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared, was all derived from simply just this shape. The shape of the cube derived our pattern of a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Isn't that cool? Okay, I am not going to wait for your answer, but that's going to be it for 3.4 factoring polynomials. We're going to be solving some polynomials next time. And if you like it, share it. If you have any course suggestions, then message me right down below. I take into acknowledgement all of the course suggestions because I don't have any course suggestions right now. If you want me to teach English, which I probably won't, but I might. If you suck at English, I might give you some essay tips. I don't know, but that's gonna be it for today's lesson. Tune in for tomorrow's lesson. I don't think I'm gonna make one tomorrow. Tune in for next lesson.